First law of thermodynamics. Every time you drive a car, turn on an air conditioner, or use an electrical appliance, you reap the practical benefits of thermodynamics, the study of relationships involving heat, mechanical work, and other aspects of energy and energy transfer. Liquefaction of a gas is an example of a thermodynamic process. Here the gas is compressed to a very high pressure while keeping the temperature constant, and then it is insulated and allowed to expand. The gas cools so much during the expansion that it liquefies. A thermodynamic system is a system that can interact and exchange energy with its surroundings or environment in at least two ways, one of which is heat transfer. The first and second laws of thermodynamics tell us about the transfer of heat. Let us now discuss the first law of thermodynamics. The first law of thermodynamics states that the amount of heat given to a system is equal to the sum of the increase in internal energy of the system and the external work done. Delta Q is equal to delta U plus delta W, where delta Q is the amount of heat energy supplied to the system. Delta U is the increase in internal energy. Delta W is the external work done. The first law of thermodynamics is an extension of the principle of conservation of energy. It broadens this principle to include energy exchange by both heat transfer and mechanical work, and introduces the concept of the internal energy of a system. For a cyclic process, delta U is equal to 0. Hence, delta Q is equal to delta W. For an isolated system, delta Q is equal to 0. Delta W is equal to 0. So, delta U is equal to 0. Popping of corns from their kernels is an example of a thermodynamic process. Let us see why it is considered as a thermodynamic process. When the pot is placed on a stove, the corn absorbs the heat energy by conduction. As the corn pops and expands, it does the work because it exerts an upward force on the lid and moves it. The state of corn changes in this process. That is, the heat supplied is used to bring about change in the internal energy of the corn and to do work. Thus, popping of corns obeys the first law of thermodynamics. Applications of the first law of thermodynamics. The first law of thermodynamics can be applied to find the latent heat of vaporization. Is used to calculate the quantity of heat required to raise the temperature of an ideal gas.